All right, hi everyone. Welcome to our lecture on confounding. I can't remember what week this is. I think it's 8. Okay, so today's class, we're going to go through a few different aspects of confounding. First of all, what is it? How do I know I have it? And then what do I do about it? And if you've been paying attention all along, which I think all of you have, you'll notice that we've talked about confounding in many different lectures up until this point, but we've only sort of teased at it. I think you guys are starting to get a feel for what it is, but today we're going to go full on into confounding. So I often feel like confounding in this lecture in particularly is really the missing piece. And I often don't know where to place it over the course of the semester because it's like, should I give it to you all up front or sort of tease you with these little bits as I've done? So every year I do it a little differently, and hopefully it's working for you this year. So finally, we will this week address our missing piece, which is the topic of confounding. Okay. So just to orient you in terms of sort of a real life example. So say you were investigating a situation or an outbreak of a foodborne disease. There was a church picnic with 200 people. People start getting violently ill, come down, you figure out it's salmonella, and you need to figure out, well, what caused it? What food product at this church picnic was really the culprit? And so say you conducted your study and you found out that the association between consumption of mayonnaise and salmonella got you a relative risk of 4.3. So that is people who consumed mayonnaise at this church picnic had a 330% increased risk of being infected with salmonella. So you can ask two questions once you come up with this relative risk that now all of you know how to calculate. You can ask, is this actually a causal effect? Was it that mayonnaise truly did cause increases in salmonella or cause salmonella? Or what are my alternatives, right? And so last week we talked about, could this be random error? Did I just have such an awful measure of food intake that I'm getting these spurious results? Could this be a situation of bias, that people misreported things, we collected information correctly, who we recruited into our study was not representative of the distribution of outcome and disease in our population? And then there's a third question, which is, could this be confounding? Could there be some other variable, in this case some other probably food product, that's actually perhaps to blame for the salmonella, and it's associated with mayonnaise, and therefore it's looking like the culprit is mayonnaise, but it's not. Oh, I lost a slide. I think we come back to it later about what those other things could be. Okay. So confounding arises when an observed association between an exposure and a disease, so in that case, our mayonnaise and our salmonella, is to some extent due to a third unaccounted for factor. So it may be, right, that some third factor is completely the reason why we see an association between our exposure and our outcome. And once we account for that third factor, that association goes away. We get down to a relative risk of 1. Most situations are not that clear cut. In most situations, the third factors or the confounders are maybe accounting for a little bit of the association, but you may still see a strong association there between your exposure and your outcome. There's another situation that could occur where your confounder is actually masking a true relationship between your exposure and your outcome. So you may do your study and see end up with a relative risk of 1, and then you say, gosh, I didn't account for the fact that there's this third factor. And when you account for that third factor, all of a sudden you see that there actually is an association between your exposure and your outcome of interest. So there's a lot of things that really could be happening with confounding. And I like to point that out early because I think a lot of our examples are very simplistic. And when we're first introduced to this idea of confounding, like in this class, we say, oh, I saw an association and then I took into account my third factor and I realized it was all because of an unequal distribution of race or gender or something else, and then my association went away. And that's just very simplistic, and it doesn't normally happen that way, even though that's how we're going to learn it. Okay, so we have our exposure, we have outcome, we have a third factor that may actually be the culprit, may be the thing that's driving the association that you observe. That third factor is a confounder. And not accounting for that in our studies distorts the exposure-outcome relationship. It introduces bias or error, as we learned about last week. Okay, so here's my food thing. So the question is it truly that mayonnaise is causing the salmonella, or are there other foods or other circumstances that go along with that mayonnaise that may be to blame, that are also, or actually in fact, are true risk factors for salmonella, right? So it could be eggs, right? So if there was an egg salad and it was actually the eggs and not the mayonnaise, it could be the eggs that are the culprit. It could be tuna, similarly, tuna salad. It could be the chicken, right? All these things that are sort of correlated with eating mayonnaise, they go together. Could be cold cuts, right? Everyone had their hoagies and there was mayonnaise on them, but it was actually the cold cuts. Or it could be a food handler. So maybe it was a food handler that it was getting people sick, and it just happened to be that food handler was also handling the mayonnaise. Okay, so as you can see here, there are a lot of things that are correlated with mayonnaise intake. And it might be the situation in this church picnic that was actually one of these other exposures that's the source of the salmonella, and the mayonnaise was just sort of along for the ride, right? And we'll talk about how we can tease this apart. We can also come back to our sort of classic silly example of confounding that we introduced very early on, and we've talked about a few times over the course of this course. So the question of, does carrying a lighter cause you to have lung cancer, right? And we've talked about this before, that what is correlated, what sort of goes along with carrying a lighter, is smoking. And that, in fact, right, smoking is the true cause of lung cancer. But because smokers happen to carry lighters, it's going to end up looking like there's an association between carrying a lighter and lung cancer. You'd end up with a relative risk or an odds ratio greater than 1 when you're looking at the association between carrying a lighter and lung cancer. So here's a real world example to give you an even more sort of hands-on sense of this idea of confounding. So there was a question of whether there is actually an association between birth order and Down syndromes. And this question came about because researchers conducted a cross-sectional survey. So remember, cross-sectional study is study one point in time. And they found a higher prevalence of Down syndrome among children who were higher in the birth order, right? So if that were a causal association, that would mean that being later in the birth order caused you to have a higher risk of Down syndrome. Okay, and so if we cross-sectionally looked at these numbers, we would see, and I'll orient you to this figure. So we have birth order along the x-axis. You could be the first child, second, third, fourth, or fifth or more. And among our y-axis is affected babies per 1,000 live births. So this is a measure of the prevalence of Down syndrome. And so we can see that if you're the first child or among first children, the prevalence of Down syndrome was 0.6 per 1,000 live births. Meanwhile, if you were the fifth child or later, the prevalence of Down syndrome is 1.6 per 1,000 births. So that's almost a threefold increase comparing Down syndrome among firstborn babies to Down syndrome among babies born fifth in the birth order or later. Okay, so you'll start to realize we're using these little triangles, right? So we have our exposure of interest, birth order. We have our outcome of interest, Down syndrome. And here we start to have our third factor, our potential confounder. And the issue that comes about here is that, hey, naturally, as you're a later born baby in your family, your mother is going to be older. So it raises the question, is it actually birth order that matters, or is it maternal age? And that birth order and maternal age are naturally correlated because mothers are going to be older with their later children. And so here you can see birth order and our third factor, maternal age, are correlated. That's how we indicate that with this line here. This line doesn't necessarily show a direction, right? Because it's not that maternal age caused the birth order. It's just that these two are correlated. We're indicating that with that line. But we do actually know that maternal age is a risk factor, so we can draw an arrow in this direction for Down syndrome, right? And so we start to establish our triangles, excuse me, and this raises the question of, is it actually birth order or is it maternal age? And so what we can do is we can look at the same relationship or a similar relationship that we looked to earlier, but here along our x-axis we have maternal age, and you can see that for women who have babies over 40, the risk of Down syndrome is incredibly high. And this is adding to our evidence, right, that this arrow is true, and it really again starts to raise the question of how much of the association between birth order and Down syndrome is actually due to maternal age. Okay, so what we can do to solve this problem is separate out the exposure of birth order from the exposure of maternal age. And this figure is sort of 3D here, has 3 axes, so I'll walk you through it. So for women who have babies, you know, let's say earlier than 30, so are younger than 20s, 20 to 24, 25 to 29, among these 3 groups here, you can see that it doesn't matter the birth order, that the prevalence of Down syndrome is very low. But then among the 35 to 39-year-olds, and then among the 40 plus, again, doesn't matter in respect to birth order that the prevalence of Down syndrome is very high. So if you take all of this together, you'll start to see that birth order, there's basically no association between birth order and prevalence of Down syndrome once you take into account maternal age. And the way we're taking into account maternal age here is we're looking within strata of maternal age, strata or groupings of maternal age. So it's not just babies born to all women, all ages clustered together. We're looking within certain age groups or strata. Okay, so as I introduced you to before, confounding is often represented by this triangle. And the triangle is our exposure-outcome relationship, and then we include our third factors, which, and we'll go through the rules in a little bit, but it needs to be associated with our exposure and a risk factor for our outcome. And that's how we develop our triangles. Okay, so here are specific criteria. Again, as I was saying, the third factor must be associated with our exposure. It must be a risk factor for our outcome. And one other rule that I haven't talked about yet, it must not result from the exposure. And this is also known as it cannot be on the causal pathway. And I'll show you the example of this. Okay, so let's look at some triangles. So here's our typical setup. Third factor is associated with our exposure, a risk factor for our outcome, and it's not on the causal pathway. It's not that the exposure leads to the third factor that then leads to the outcome. We can also look at this situation, and this is something, if it helps you remember, it's the third factor is the common. See, I have this backwards and I forgot to correct it from last year. Now I'm remembering it was wrong last year. Basically, I will edit that right now. The third factor is a common cause of the exposure and outcome. Okay, so this is also a situation where there's confounding. So it may be that the third factor leads to the exposure and then leads to the outcome. And so what happens when you try to look at the relationship between the exposure and the outcome, the true association is masked by the presence of this third factor, which is a common cause of both of these things. And we'll go through some specific examples. Now here's a case where this is not confounding. So if you see a triangle that's set up like this, so here's our exposure. Our exposure is leading to our third factor, and that's leading to our outcome. This is a situation where the third factor is on the causal pathway. It's on the road between exposure and outcome. And this is a situation where the third factor is actually something called a mediator. It's in the middle. So an example of this, I'm actually writing a grant right now to look at childhood trauma and diabetes and questioning, is there a relationship? Does early childhood traumas and severe stressors increase your risk for diabetes as an adult? And one of our third factors is actually obesity, because we know that trauma contributes to obesity risk, say during adolescence and early young adulthoods. And of course, we know that obesity is a really strong risk factor for diabetes. So that's a case where obesity is a mediator of the relationship between childhood trauma and diabetes, and we would not deal with it as a confounder. And we'll learn in a minute how to deal with confounders, but if you did inappropriately deal with a mediator as a confounder and sort of take away the part of the relationship that is due to your third factor, so in this case obesity, what you'd end up seeing is you'd answer the question of what is the relationship between the exposure and the outcome without or independent of my third factor. And oftentimes you don't want to know that, right? Do I really want to know what's the relationship between early childhood trauma and diabetes taking away obesity? Or if obesity, among non-obese people, well, that's actually sort of interesting, but independent of obesity. So it might be interesting, but it's not the question you're setting out to answer most of the time. So bottom line, be very wary of your mediators. Okay, so let me go through a few examples, and this is, as you may imagine, much more entertaining if we were in a class and we could talk about these things, but I'll talk through my perspectives on it, and you can decide you agree with me or not agree with me and email me. So we have our exposure, which is hormone replacement therapy. You may not remember, but way back we talked about hormone replacement therapy. And the question is hormone replacement therapy use a risk factor for heart disease? And to answer this question, though, you're going to want to consider, is socioeconomic status a third factor? So is there some association between socioeconomic status in hormone replacement therapy that I need to be cognizant of and aware of? So let's start to fill in the arrows. Let me see if I fill in the arrows. Nope, I don't. So we know that people of lower socioeconomic status are more likely to have heart disease. So we can fill in an arrow between socioeconomic status and heart disease where there's actually an inverse relationship. Lower socioeconomic status, increased risk of heart disease. We might also say that there's an association between hormone replacement therapy and socioeconomic status. Perhaps higher income women are more likely to use hormone replacement therapy because they have a good insurance that covers their use. They're more likely to see their doctor, something like that. So in this case, we may say we have a positive association between hormone replacement therapy and socioeconomic status. And if those are the situations, then we start to think, oh gosh, I might have confounding by socioeconomic status, right? Our third criteria is your confounder is not on the causal pathway. And we don't believe that hormone replacement therapy use leads to your socioeconomic status, which then leads to heart disease. So we feel pretty good that we can meet that criteria. So I would say, just thinking through and our knowledge of this situation, I would say yes, the confounding criteria are met in this relationship. We're going to learn at the end of this video sort of how to test for confounding and how to get rid of confounding. And I'll tell you right now, if you've ever taken another epi class, or if you perhaps do in the future, a lot of courses rely on those sort of mathematical checks to determine confounding. I like to start with my students much more from a place of thinking and what is our background knowledge and what do we know about the way the world works, and then we start to identify our confounders and move forward. But I think it's important to start from our knowledge in the literature rather than sort of blindly testing or picking and choosing what our confounders are. So here's another example. And the question here is, does the BRCA1 gene lead to breast cancer? And you may be conducting a study to evaluate this question, and you start to think, do I need to take into account women's age? Is there something about, could it be that, the presence of the gene or could it be that any association I observe between this gene and breast cancer is actually due to some differences in age in my study sample? So let's start with the first question, or the first criteria. Our exposure and our third factor are correlated with each other. Well, we can stop right there. Whether or not you have a genetic predisposition or a specific, allele is unrelated to your age, right? You're born with that. It's developed from the time you were an egg and sperm, and it's unrelated to the age. So in this case, we could not draw an association between presence of the gene and age, and so age would not be a confounding factor in this relationship. And you would not need to say, gosh, is some of my relationship or all of my relationship actually accountable or due to age here? So no, age is not a confounder of this relationship. One more here. The question is, you say you wanted to do a study and you wanted to find out whether alcohol intake, probably higher alcohol intake, is a risk factor for HPV. And you start to go through your confounding criteria. And you start to wonder, is unprotected sex some third factor that I need to be considerate of and I need to somehow address because it's masking the true relationship that I want to see between alcohol intake and HPV? So what you start to think about is actually, maybe the way the world works is that higher alcohol intake increases your risk of unprotected sex, and that then increases your risk of HPV. And if that's the case, then you don't want to treat unprotected sex as a confounder. You'd want to treat it as a mediator and not sort of take away the amount of association attributable, in this case, to unprotected sex. So I would say no. In this case, unprotected sex is a mediator of our association between alcohol intake and HPV. Okay, so in the past we've talked about the counterfactual. What would have happened in the world if one thing were changed? And the counterfactual and our understanding of the counterfactual directly relates to confounding. So let's talk about this. So confounding occurs, our interference by our third factor occurs because our exposed and our unexposed group differs from our exposed groups in ways that affect the incidence of the outcome. So there's something different about our exposed group and our unexposed group. And specifically, that different thing is that our third factor is unequally distributed in our exposed group and our unexposed group. So I'm going to go back to this example. So for example, we have our women who use HRT and our women who don't use HRT, and socioeconomic status is not equally distributed across those groups. There are more high SES women in our HRT group than in our non-HRT group. So our exposed and our unexposed, our HRT and our no HRT, are not the counterfactuals to each other. They differ based on more than just one key factor, more than just whether you use HRT. They differ in socioeconomic status. They are not the counterfactual to each other, and that unbalancing of socioeconomic status among our exposed and our unexposed groups means that we can't tease apart, is it actually the HRT or is it the socioeconomic status, because there are at least two different things going on in our exposed and our unexposed groups. They are not the counterfactual to each other. It's not that the only thing different is HRT use. Okay, so as I was saying, confounding occurs because the exposed and unexposed groups differ in ways that affect the incidence of the outcome. They're not balanced on factors that are important for the outcome. In the case before, socioeconomic status and heart disease. And so our unexposed group is not the same as the exposed group, but for the exposure. These two groups cannot serve as the counterfactuals to each other. They are different in ways, more than one way than just our exposure. They're different in the distribution of our third factors across them. Okay, So we always want to compare apples to apples when we're trying to determine the causal effect of an exposure. In this case with our apples, we want to know, does the apple being red matter? And so we'd want a situation where the only difference between our apples is the color. But what happens with confounding is that we end up comparing apples to oranges, that these two, our exposed and our unexposed group, are different in lots of ways, not just the exposure. And those ways that they're different matter for the outcome. Those differences are independent, are actually risk or protective factors from our outcome. And so what happens is that we can't tease apart, is it our exposure of interest, or is it these other third factors that are unequally distributed between our exposed and our unexposed groups? Okay, so that's the deal with the counterfactual. And as hopefully you can see that this idea of confounding is directly related to the issue of the counterfactual, or the concept of the counterfactual. And now last week we talked about selection information bias, and a lot of people sort of get tripped up on, is confounding a bias? Is it the same as selection bias? So let's just talk through this for a minute. Confounding, confounding is a different type of bias. When your relationships are confounded, when you're mixing up the effects of your exposure and your third factors, your resulting measure of association, your relative risk or your odds ratio, is a biased estimate. It's a wrong estimate. Now, the difference, though, between confounding and the types of bias we learned about last week is that selection bias and information bias are due to errors in the way we do our studies. Remember, selection bias is errors in who comes in and who continues to be in our studies. Information bias are errors in the data we collect. They're the fault of the investigator. They're, something that could have been eliminated if we have done our study differently. Confounding is different because it's not the fault of the investigator. Confounding reflects unevenly distributed characteristics in our population. It's the fact that certain things correlate together. Drinking and smoking are correlated. High SES individuals tend to be exposed to lots of things that low SES individuals aren't, and vice versa. This is naturally the way the world works. And so when we conduct our observational studies, our cohort studies, and our case control studies, and we're not explicitly assigning our exposure, that we're just watching the way the world works, we're going to end up with confounding because, again, it's what happens, that exposures cluster together. And so again, confounding reflects unevenly distributed in the population. It's not an error of the investigator in the way they've conducted their study if they end up with confounding. It's a fact of the world that these things cluster, our exposures cluster. Another difference between selection bias, information bias, and confounding is that confounding actually can be addressed after the study has been conducted. Thank goodness, right? Because if it's something that naturally happens in the world when we conduct our observational studies, then we need a way to deal with it, or else we're in big trouble, and all of our measures of association are completely biased. So there are strategies we can take to address confounding after the study has been conducted, with the caveat that we need to have measured our third factors, right? Because you can't deal with something, you can't deal with the fact that SES is sort of correlated and clustered with all these other things unless we know something about the individual's SES. So that's the caveat, that it can be addressed if we have measured our third factors. So I talked about this a little earlier. If we don't take into account our third factors and try in some ways to solve the confounding, we may end up seeing an overestimate of the strength of our true association. So in that case, our exposure outcome relationship may be farther away from the null than it is in truth, than it should be if we had taken into account these third factors. Or, as I mentioned earlier, we may actually end up with an underestimate of the strength of the true association. You may see a relative risk that's very close to 1 and say, oh, there's nothing going on there. But all of a sudden, then you take into account the third factors, whether it's race or education or gender or use of some other medication or anything, right? And all of a sudden, once you take that confounding into into account, your measure of association goes farther away from the null, and you end up with a stronger measure of association. Okay, so I said this earlier, how do I know when I have confounding? It starts to become a bit overwhelming when we think about all the ways that things are clustered in our world and things are correlated, and people who tend to do this tend to do that. And how do I start to separate that out? So how do I know I have confounding? As I mentioned earlier, draw on your background knowledge, draw on your knowledge of the literature. Where have we seen associations before? What do we know about certain social groups or the biology of people? What do we know about things that sort of go together? Also draw out your relationships. I can't tell you how many times, probably on a daily basis, I sit down and I draw out my relationships and I really start to think about, you know, are these two things associated? Is this actually on the causal pathway? Do I think this came before this, sort of in the real world, not necessarily always my epidemiology study world? Draw the way the world works, and you can start to say, oh, I need to take this into account. I need to make sure that this third factor is equally distributed across my exposed and unexposed groups, or else what I'm going to see is actually a reflection of that third factor and not my exposure of interest. And then after you sort of know what you're looking for, data can be used to confirm that your third factor meets all the criteria. And we're going to walk through that. And finally, sometimes you just don't know. There always is unmeasured confounding when we do observational studies, because there's just a myriad of ways that our exposed and unexposed groups are not the counterfactual to each other, and it's nearly impossible to say for certain that we've measured everything important. Don't give up hope though, because really what probably matters the most is that we've taken into account the important things. If smoking is just this incredible confounder that's going to mask your relationships because your exposed group are almost all non-smokers and your unexposed group are almost all smokers, and you just can't tease apart smoking and smoking and your exposure of interest, then you're in trouble. But if you've accounted for your major confounders, you can with some certainty start to say, I don't think my measure of relative risk, if I see a really strong measure of relative risk, I don't think it's going to vary that much by all these confounders that I don't know about. For most health situations, we have enough knowledge in the world, and hopefully you've collected data to be able to account for those confounders. And this actually, I'll tell you, relates back to one of our Bradford Hill criteria. If you remember from our lecture way back before the midterm, strength of association was one of our causal criteria. And the idea there is that if you have a really strong association, if you have your smoking and lung cancer relative risk of 17, and there's pretty much, there just can't be confounders that we haven't thought about that are going to take you from a relative risk of 17 times the risk to no increased risk. It's hard to think of what those would mean. We've taken into account a lot of the confounders, a lot of the behaviors that go along with smoking and the social circumstances that go along with smoking. So the stronger your strength of association, the less likely that you have some unmeasured confounding that you haven't taken into account.